In this video, I'm going to go over the answers to questions 7 to 12. Here is question 7. You can see it's worth 4 marks and it's a log equation question. Now, we can see that we've got the same base and we've got two things that we've taken the log of. The first one is x plus 2 and the second one is 2x plus 1. And when you take the logs and add them, the answer is 2. Now, there's a rule that we must use here, and it's this one. When you've got the same base, log m of to base b plus log n to base b is equal to log of them multiplied together, mn. So here's what we have. M is equal to the first bracket, n is equal to the second bracket. So when we take the left-hand side, we can then go log of the two brackets multiplied together, base 3 is equal to 2. Now when you take the log of a number, the answer 2 is the power to which 3 is raised to give you this number, the x plus 2 and the 2x plus 1. So we can say that the two brackets multiplied together must be equal to 3 to the power 2, which equals 9. Now that's a quadratic equation. The best thing to do is multiply out the left-hand side, then take the 9 to the left, tidy it up so you get 0. Now you've got the standard quadratic equation. Let's factorise if we can, and we can. That's what the factors become, and then the two answers will be x equals negative 7 over 2 or x equals 1. But if we go and look at the question, it says x is greater than negative a half. This is not, so take that out, and the answer is x equals 1, 4 marks. Next question. A standard circle question. You've given the centre and a point on the circumference, and we want to get the equation of the circle. Well, here is the law, the general law, equation of a circle, centre AB. AB, we know, is negative 3, 5, and R, we have to work that out now. So we're going to join C to T, that's the radius, and I'm going to make a right angle triangle. Let's work out the base. You start at negative 3, you go to 1, that's a jump to the right of 4. You start at 5, you go up to 8, so that's a jump of 3. A 3, 4, the hypotenuse must be 5. It's a 3, 4, 5 triangle. You've seen that many times. So now we've got the answer to A. It's going to be x plus 3 all squared plus y minus 5 all squared equals 25. Don't forget to square the 5 because it says r squared here. The second one is ST is a diameter. Now we can find the point S if we just make a copy of that, so that to work out how to get from T to S, let's look at the x coordinate. You start at 1, you go 4 to the left, 4 to the left, so that's 1 take away 8. Now how about the y? You start 8 up, you go 3 down, and you go another 3 down, and you get to S. So we now get the point S. S is the point, 1 take away 8, 8 take away 6, so it's negative 7, 2. Okay, now we need to find the gradient of this. The gradient of ST is 6 over 8. How do I get it? Well, if I go from S to T, I've got to go up 6, which is the Y shift, and across to the right 8, 4 and 4. So that's where the 6 and 8 comes from. Reducing it down to a simplest form gives you 3/4. Now, we want the equation of the tangent. The tangent makes a right angle with the radius, CS. And this is the gradient of the line CS or ST, it's the same thing. So we know that when you've got a radius and a tangent, they are perpendicular, and perpendicular lines multiply to give -1. So the gradient of the tangent will be negative 4 over 3. How do I get that? Turn that upside down and make it negative. Now if you multiply this one by that one, you get -1. So we're almost finished. We've got a point, we've got the gradient. All we need to do is get the equation of a tangent. It's given by this formula. Put A and B into the equation from there, and there's the gradient. So we do that. Let's multiply by everything by 3, and then that will give me -4 times this right-hand bracket. So we're going to do that all at once. 3y take away 6 equals -4x take away 28. And then I'm going to bring everything to the left, so I get 4x plus 3y plus 22, because 28 will become minus 28 will become plus 28, take away 6. And there's the answer for 4 marks. In total, 6 marks. Okay, move on to question 9. This time we want to find the coordinate, the x-coordinate of the stationary point on this curve. Okay, let's write down the curve. To find a stationary point, we have to differentiate first. So we can't do that because we don't have a power. We've got a root, so we will change it into the power form, and it equals that. Remember, to get this, the 3 is the power, it goes up, and the root is the 2 square root, so it goes down. Now then, we know that the stationary point, at a stationary point, the gradient of the tangent, no, we've got, sorry, I've got to do the differentiate first, sorry about that. So differentiate first means you've got to bring the 3 over 2 down, multiply with the 2, and then reduce the power from 3/2 to 1/2 by subtracting 1. The 2's will cancel to leave 3 times x to the power of 1/2, take away 6, but x to the power of 1/2 is root x, so there it is. Now, a stationary point, the stationary point is when f dashed of x equals 0. So this thing here has to equal 0. Take 6 across, negative 6 across, divide by 3, you get root x is 2, so x equals 4. Now, that's the first one. That is the first answer, x equals 4. Second one says, determine the greatest and least values of y in this interval for x. So let's take the 2 endpoints. When x equals 1, that will give us y, if we go back to this equation, it's 2 times the square root of 1 cubed, take away 6 times 1. That's 1 times 2, take away 6 is negative 4. Let's do the same for the other one, which is the other end, which is the bigger value for x, and it gives you x equals 9. Now, we just put 9 into that equation there for x. When you want to evaluate the square root of 9 cubed, it's much easier to do the square root first and then take that answer to the power 3, like this. So we can do the square root of 9 is 3, 3 by 3 by 3 is 27, 2 27s are 54, 9 6 is 54, when you subtract you get 0. Now, we better check the stationary point because it's between 1 and 9 and see what the value for y is. So we do that the same way. X equals 4 will give y is 2 times 4 cubed, take away 6 times 4. Just putting 4 into this equation up here. So again, don't cube the 4, square root the 4 and then cube it. Same as it did the last time. The square root of 4 is 2, 2 cubed is 8, 2 8s are 16, 6 4s are 24, 16 take away 24 is negative 8. Now we want to get the greatest and the least values, so let's check. The greatest appears to be 0 and the least is negative 8. So there you go, finish it off. For x in this range, the maximum value, the greatest, is 0 and the minimum value, the least, is negative 8. Okay, number 10 is a classic example of transformation of a graph. Now, if we look at what we have to do, we're given this graph, it's got a turning point there and a point of inflection here, and all we need to do is to try to work out the graph. The new graph is negative f of x plus 3. So there's two things happening to the parent function f of x. F of x is becoming x plus 3 first, which is shift 3 units to the left, and then after that you take the negative of that answer, which is the parent function would be f of x. If you do a negative you reflect in the x-axis. So let's try and show that. There's the graph. I put it in red. We shift it to the left 3. Shift it to the left 3, which means that this point of inflection goes to the origin, but then we have to flip it upside down over the x-axis, and there it is. So before we finish this, we better put some points on. We know that this point is 0 0 because it moved 3. This point also moved 3, so it's going to be negative 3 across, and it's going to be how far up? 4. So it's going to have to be negative 3, 4. Now that's it. That's what you have to do for that one. Now the second one I'm going to do on the next page, we want to draw a sketch of the derivative function f dash of x of the original function. So here it is. There's the original function. How do we draw the derivative? The best thing to do is just to draw axes below it in line, and we have to points that are important. We know that this is the x and this is the differentiated y dashed. Okay, it's y dashed x. Now, we can see a turning point. We know the gradient at a turning point is 0, so we can put that point in down there. We have a point of inflection, which is also a stationary point, so we can put that point down, and then it's going to be the same there, 3. So these are 2 points that are going to be on my graph. Now we have to go back to the original graph and see what's happening. If we look at the left of 0, we can see that the slope is going down. It's a negative. If we go to x is 0, then we've got a stationary point, so it's going to be a gradient 0. When we go between 0 and 3 for x, it's rising, which is a positive gradient. And then we have a 0 gradient at 3, and then we go up again. Now, we know that on this part, it's negative, which means that before we go to 0 on this line, we have to draw the graph somewhere in there. Okay, then after that, it starts to rise, so it's going to be, the gradient is going to be positive, so it's going to be in that region somewhere there. And then it gets to 0 there, and then after that, it goes up to the right, so we're going to have a part of the graph in there. But it must come back down to hit 0, because we know that it's going to be, it's going to have to be 0 down there. So we're going to have got 1 point, 2 points, a point there, a point there, and a point there. Let's just draw it now. There it is. And you can see that on the left, it's negative. In this part, it's positive, then negative. No, beg your pardon, positive and positive, but it's getting smaller, and then it goes up again. Now that's what you would want to do for that sketch. Quite tricky, I know, but that's what you have to do. Okay then, question 11. Now this time we have a line which cuts the y-axis at 5, and we want to determine the angle the line makes with the positive direction of the x-axis. There it is shown there. So what we should know is the gradient of a line equals the tangent of the angle that the line makes with the positive direction of the x-axis. So it's a tangent of this angle here. Now, we also know something about this. There's the equation of the line. If we change this around, then we can say y equals mx plus c. We can put it into mx plus c. So we can get the gradient from that. The gradient of that line will be negative root 3. Okay, so what do we know? We know that the gradient is negative root 3, but it also equals tan of the angle shown. So we can then say tan of the angle shown, that's alpha in my case, is negative root 3. We don't have a calculator, so you have to go and try to do this by finding out which angle has a tan of negative root 3. Well, here we go. The best way to do it is to draw a right angle, a nice equilateral triangle, so that all the angles are 60, and then you make the lines 2, 2, and 2. Then you split it into 2 right angle triangles, 30, 60, 90, right? That's 30, 60, 90. Now we know that if this comes straight down, then we have 1 there and 1 there. And then, of course, to get this one, it's just Pythagoras. It's going to be root 3, because it's 2 squared, take away 1 squared, and then square root, it's 3. Now the angle, we want it to be tan of 60 is root 3, because this is a negative root 3, but we've got root 3 over 1 is tan of this angle, because there's the opposite, there's the adjacent. So that angle is 60, but we want it to be in the second quadrant because the tan is a negative number. So the answer is going to be alpha equals 180 take away 60. So the angle it makes, this angle here, becomes 120 degrees, and that's worth 3 marks. Okay, we come to the last question, question 12. It's worth 6 marks in total. The first part says express 3x squared take away 6x plus 4 in this form. This is a completed square form. So we have to complete the square of this expression here. So let's start. We write down the expression. We want x squared to be a single x squared, so we'll have to factorise this, take out a common factor 3, and we get 3x squared to take away 2x, because that will give you minus 6x, and then when you divide 4 by 3, you get 4 over 3, and there it is. Now, we need to try to make this part here, the first two terms, we've got to add something to make it a perfect square. So what you do is you take half the coefficient of x and you square it. So minus 2 is the coefficient, you half it, minus 1, you square it, 1, you add it, and then take it away like this. So to get this 1 here, you half that, square it, and you get the 1, but take away 1 to make it the same as the line above. Now, we can put these two terms together and get 1/3, and then we go 3 times the first 3 terms plus 3 times the last term. Now this bracket here can be written as a perfect square. It can be written as 3 times the perfect square, x minus 1 all squared, and the last part is plus 3 times a third, which is plus 1. And that is the same form as you see up there. A is equal to 3, B is equal to negative 1, and C is equal to 1. And part B, you want to show that this equation, this function, is strictly increasing for all x on the real number system. So there is there's the equation. We need to differentiate dy by dx. Now, we actually get the same as we got in part A, so we can change this part into the answer that we got for part A, and that's going to help us. Now, a function is increasing when the derivative is never 0 or never negative. Let's check. If you put any number in there for x, if you square it, you're going to get a positive number all the time. Multiplied by 3 is a positive, add 1's still a positive, so you're going to have that the gradient of the tangent at any point is going to be bigger than 0, and that means that y is strictly increasing for all x on R. And that's the end of the paper.